Hello, everyone. So today we are going to be solving for a specific variable. Hopefully this is a little bit of review. So if you feel that you might know what to do, it might be a great idea to pause the video and then see if your answer matches mine, or you can go along with me. Either way, it's fine. So this first thing we're going to do here is, of course, we have to identify what variable they want us to isolate it by itself, right? So sometimes we're just solving an equation because there's only one variable, or there's multiple variables. And one of the biggest mistakes that we will do is in the middle of us trying to isolate a variable, we forget what variable we're solving for. So one of the strategies that I use, and you don't have to use this is up to you, is I always indicate whatever variable they want me to use. Do that. I actually circle it and I keep going back to it, okay? Now, when we're isolating a variable, we're getting it by itself. The idea is it's on a certain side and we want to have everything else go to the other side of the equal sign, depending on what side it's on, right? Now, the way to balance and move things, as we would say, is we would use the inverse operation. So almost like the opposite operation. If you see addition, to move it, you're going to subtract. To see multiplication, you're going to divide, so on and so on. And throughout the year, we'll be able to look at different functions, even new functions that allow us to kind of what we say, get rid of it, right? Okay, so here we're going to get x by itself. So here I have a 4 and a 1 on this side, and I have to move it over. With solving for a variable, you always do what's furthest away on that same side. So what's furthest away is that 1. I see it's an adding 1. So to get rid of it, I subtract 1. Right? That would get rid of it. That cancels it, right? Gives us 0. But whatever we do to one side, we must do to the other. So right now we have 4x equals 16. I'm still solving for x. Now, if I had a lot of variables and I was confused, I might circle it again. But I know I'm just getting x by itself. So this is 4 times x. So how do you get rid of multiplication? You divide it. So x equals, and then 16 divided by 4 is 4. Okay, I'm not going to show all steps like this. I will say it, but I won't show it to save space. So make sure that if you need to show the operation, you do that. Okay. Now, example 2. Again, we have an x and a y, but what does it want us to solve for? It wants us to solve for y. So I want to get y by itself. So what's on the same side as y? Well, there's 4x and there's 2. What's furthest away from y? Well, the furthest away from y is 4x. Okay, now here's where you want to be careful. 4 and x are multiplying to each other. But what is it doing to y? Because that's what we're focused on, y. What is 4x doing to y? It's adding on. So how do you get rid of it? You subtract it. Whatever we do to one side, we do to the other. On this left side, we're left with 2y equals 12 minus 4x. Again, we're getting y by itself. How do you get rid of that 2? Well, I divide it. Now, if you want, guys, you can have 12 minus 4x all over 2, or you can simplify it. So 12 divided by 2 is 6, minus 4 divided by 2 is 2. And then x right there. Okay, either way is fine with me if you simplify it or not. Okay, I'll circle that because that was our final answer. All right, let's get into some more trickier things. So we're solving for x. We're trying to get x by itself here. So we have a lot on this side that's with x. Well, what's furthest away is this whole y minus 8 squared. What is that whole section doing to x right now? It's adding. So how do I get rid of it? I subtract it. I don't do it in pieces because all of it is adding to, oops, sorry guys, adding to x, y minus 8 squared. Okay, let me rewrite that so it looks better. This is what happens when you write with pen. So on this side, we have x plus 1 squared equals 4 minus this y minus 8 squared. Okay, good so far? Again, I'm getting rid of, or I'm getting x by itself. So I have this 1 and square. Which operation is further away? The adding 1 or the squaring? Well, it's the outside, almost like a present or wrapping, right? So how do you get rid of a square? Well, to get rid of a square, you do the square root. So I'm going to take the square root of both sides. On the left side, it gets rid of the square. On the right side, we take the square root. This is what it looks like. But there's one tricky thing that you need to keep in mind. When you take the square root, how many answers do you get? You get 2. You get plus and minus. Another common mistake people forget, okay, other than the plus and minus, is that they forget that just because 4 is a perfect square, and you're like, ooh, the square root and square, maybe they can get rid of. These two connect with the subtraction. You cannot take the square root of them separately. So we leave it as is. Last step to get x by itself, well, to get rid of that 1, we subtract. Now, you can put it on the outside here of subtracting 1, just make sure that it's not under the square root. Or what I like to do to make sure I know that it's not under the square root is I'll put it out front. So I'll put that subtracting 1, then we still have the plus or minus the square root of 4 minus parentheses y minus 8 squared. Make sure that's extended, and we are all done. Again, you cannot simplify the square root step. Example 4, because we know we got to do a lot of examples just for extra help. So n. Okay. Now, for those of you who are not familiar, this is not a n. This is a subset n. If you remember, this comes from your arithmetic series. Okay, so it's a term. Okay, the nth term. So this n is not what we're solving for. We're solving for the variable n. Okay, so that's what I'm trying to get by itself. So what's furthest away? Well, what's furthest away is that a subset 1. Okay, that's further away than that d. Okay. So that's a positive a subset 1. So how do you get rid of a positive a subset 1? We subtract it. So we get a subset n minus a subset 1 equals, and here we have this n minus 1 times d. Okay. All right, we're still solving for n here. So what's furthest away? That d is. What is d doing? It's multiplying. How do you get rid of that d? Well, to get rid of that d, we subtract. No, talking too fast, right? It's multiplying. What's the opposite of multiplying? Dividing. So a subset n minus a subset 1 divided by d, make sure all of it's under there, okay, equals n minus 1. Okay, next, get n by itself. How do you get rid of that 1? We add that. So I'm going to put it a little bit over here so I have room. Now, when we add the 1, that 1 is not divided by d. So make sure only the a subset n minus a subset 1 is over d. Then we have this adding 1, and that equals n. Okay, very good. I know a lot of examples, but I'm doing this on purpose, okay? All right, so we're solving for x. There's only one x here, so I can just solve this as a normal operation. So what would I do first? Well, what's furthest away on the same side is 9. So I'm going to, it said subtraction, so I'm going to add. 2 plus 9 is 11. How do you get rid of a square root? Well, you square both sides. What is 11 squared? Well, that is 121. And then get x by itself now. We have x minus 3. 121 minus 3 is 118. Now, of course, when it comes to something like this, and we're getting a number, just like we did in example 1, we can check our works by plugging in. 118 plus 3 is 121. The square root of 121 is 11. 11 minus 9 is 2. Good to go. All right, so what happens here with example 6? Let's see, again, we're going to just solve this. We're solving for x. What's furthest away on this side with x? Well, this 5. Now, be careful, even though this is subtraction, this 5. One of the biggest mistakes also that people make is they combine these two first. No, what is 5 doing to x? Technically, it is adding, right? How do you get rid of it? We subtract. So I got to bring down this negative 1/2 square root 5x minus 1 equals, now remember, it was 5, right? 5, so we have to subtract 5. Negative 4 minus 5 is negative 9. Okay? Now we go to this negative 1/2. What is negative 1/2 doing to the square root? It's multiplying. How do you get rid of multiplying? You divide. Divide. So we have to divide by negative 1/2. Dividing by a fraction is the same thing as multiplying by its reciprocal. Okay, so again, in your calculator, you can go negative 9 divided by negative 1/2, or you can say negative 9 times negative 2, the reciprocal. Either way, we would then get square root of 5x minus 1 equals 18. Okay, how do you get rid of the square root? Square both sides. So we get 5x minus 1 equals 324. Okay, add 1. I'm actually going to write over here so I have more space. We're going to add 1 to both sides. So we get 5x equals 325. Right? How do you get x by itself now? We need to divide by 5. So we get x equals 65. Now again, I'm not writing down every single step. I'm writing down the outcome of every step. So if you need to show that squaring on both sides, do it, okay? Or you could say on the side, start writing down square both sides. You know, make yourself hold notes, okay? All right, next one. You're like, Heckman, why are you doing 3 examples almost the same thing in a row? Must be something different because I would never make you do tons of the same thing. Okay, so x right here. What's furthest away? Well, it's at 8, right? So if we subtract 8 from both sides, we would get negative 20 on the right side. Anyone see a problem? When you take the square root of any number, square root of 4, 2, square root of 25, 5, square root of 100, 10. Can you ever square root something and get a negative number? No. You can't. So this is automatically a wrong statement, untrue. So if you want, continue, but what this is, you need to mark to yourself, square roots do not equal negative numbers, right? So when this happens, what we call it is we can say no solution, anything like that. But what they also say is extraneous. Okay. Or no solution, D&E does not exist. So on and so on. Okay. A couple more examples and then we're done for this lesson right here. Okay. So here we're solving for B. I made a mistake when printing. And so what I'm going to do is rewrite this because as you can see, if we're solving, we need an equal sign. So let's do this equaling, what did I have down here? 3. Okay. We're solving for B. Okay. So let's circle that because there's so many variables and I want to make sure that I'm looking at the correct one. So this term right here, 4AC is what's furthest away. So it's subtracting 4AC. So to get rid of it, we would add 4AC. Keep in mind, you cannot put these two terms together because they are not identical. They're not combining like terms. Okay. All right. So here we have two things that we need to do. B is squared and having the cube root. Okay, again, try to do what's outside first and then inside as we go backwards, right? So how would you get rid of a cube root? How would you get rid of a cube root? Well, to get rid of a cube root, we cube it. Okay, so when you talk about cubing, all you have to do is put it to the third. Okay, so when you have a root, you have to do the whole exponent. Okay, now how do you get rid of a square? We did this already earlier, right? So to get rid of a square, we take the square root. Now, when we take the square root, how many answers do we get? 2 plus or minus. Okay, and then we have this parentheses 3 plus 4AC cubed. Now circle that answer. Okay, awesome. 2 more. 2 more because I have another example that I want to show you just in case. Okay. All right, here we get a little bit more complicated, right? We're solving for H. Okay, we're solving for H. What's the first thing we don't like? Don't like the denominators, right? Well, denominators should make you think of division. It's a fraction, we're dividing by it, right? So how do you get rid of division? We multiply the other side. So here's what I'm going to do. I'm going to verbally say it, but write down the ending outcome, okay? It's I'm going to get rid of this r squared by multiplying the right side by r squared. I'm going to get rid of the r plus h by multiplying it by the left side, okay? So what I end up having is r plus h. Make sure you keep that in parentheses because right now they're together, times v squared equals 2g times r squared. Okay, again, you need me to repeat what I just did. Pause it, rewind. Now, there's actually 2 ways you can do this. Okay, I'm going to show you one way, and then verbally, I'm going to discuss the other way. Okay, but not write it down. All right, so here I look and I'm like, I don't like parentheses. Let me circle that H again though, so I'm remembering that's what I'm trying to get rid of. Okay, so what I might do is I don't like the parentheses, so I'm going to distribute that V squared. So I got R V squared plus H V squared equals 2G R squared. Okay, again, I'm getting h by itself. So I'm going to move the rv squared over. I'm going to subtract it over. So hv squared equals 2g r squared minus rv squared. And then how do you get h by itself now? Oh, I got to divide both sides by v squared. So we get h equals 2g r squared minus r v squared all over, because I'm dividing the whole side by v squared. Okay, now remember, I told you there was another way you could do this. I'm verbally going to say it. So you would still do the same step, okay? Now, instead of distributing the v squared out, which is multiplication, right? Because it's multiplying right there. How do you get rid of multiplication? You divide it. So actually, on this step, I could have just divided the right side by v squared and then subtracted r. That's up to you. Either answer is correct. Now I'm adding one more example and I'm putting it on the back because actually I want you to look at the example before I tell you why. So this is our example. ZR minus P equals 7 plus ZA. Solve for Z. So why did I have this different than the other ones? Well, how many Z's do you see in our problem? There's 2 of them. There's 2 of them. This is definitely an example I want to go over because we haven't done it. You got to be careful. And I think you guys can do it. All right. So you want to get Z by itself, meaning 1Z. So the first thing we have to do is get all the Z's on one side. So get the variable you want all on one side. Everything that does not have a Z, does not have the variable you want, you're going to move it to the other side. Okay, so ZA, this is adding. I want to move it over here. So what I'm going to do, of course, to get rid of adding is we subtract. All right. Now the P doesn't have a Z in it. So I want to move it to the right side. Well, this is a minus P. So to get rid of it, I add P. You guys see that? I'm moving all the Z's to one side and everything without a Z to the other. Right? Again, if you want to mark it down, say, I'm going to add P, add P, I'm going to subtract ZA, and then subtract ZA, whatever you need for your notes, okay? All right. Get Z by itself. They both have Z. Now, hopefully this sounds familiar. When terms have things that are alike, you can factor the greatest common factor. So I can pull out a Z from both of these terms. So again, I'm going to factor out a Z, leaving R minus A. Okay, take a look at that again. Factoring, pulling that out, right? These match because I could distribute that and then get that. Okay? All right. Now again, our goal was to what? Get Z by itself. This by itself. What is Z doing to the parentheses? It's multiplying. So how do you get rid of multiplication? We divide it. So we're going to divide this 7 plus P all over R minus A. Now you can use parentheses if you want, but you really don't have to. And this is our answer. All right, guys, let's get to some practice. See if if you need help, ask me whenever you need.